Minimass is a way of making low-cost, low-carbon concrete structural elements. We're using 3D printing to take material away. We're building beams for a 10-metre long bridge, 2 metres wide for pedestrian traffic. This footbridge is a first-of-a-kind demonstrator project. It will be the first Eurocode compliant structure to be made in this way.
I'm looking forward to this project and the design optimization. It's a great application for 3D construction printing, only needing to place material where necessary.
The reason why I like to work with HTL and Cobod is because we're using actual concrete. This is code compliant concrete. It comes out of the back of a ready mix wagon. Critically, the mix that we're using has aggregates in it. It gets pumped through the system until at the point of the printer nozzle, there is another hopper where the 3D printing additives are mixed in, and at that point, the consistency of the material is ready to go. It goes off quite quickly and allows you to print layer by layer. We're able to make structures where we're taking the advantages of 3D printing, giving us the freedom with geometry, but also reinforce them, and in the case of the bridge, post-tension them so that we get excellent structural performance. 3D printing gives us the chance to revolutionize how we use materials like concrete and steel. It gives us the chance to have savings in material quantities, in labor, in time, but most importantly, in cost and carbon. And these are big potential savings. So for a material reduction of the order of 50%, we can generate carbon savings at the same level, 50%, and cost savings in the region of 20 to 30%. As our bridge is a first-of-a-kind demonstrator project, we are trying to gather as much data as we absolutely can. So we're working with our project partner, Epsimon, who have given us the ability to install fibre optic strain gauges on the reinforcement in the top and the bottom. This gives us the chance to map in real time the performance of the structure for stresses and strains under the load during the lifetime. We're also measuring temperature in the concrete as we go, and that will also help us to show and demonstrate the evolution of the concrete strength and creep over time. It's possible for us to move the printer. Now, normally we will make our beams in a factory-like setting, which might be outdoors or indoors, but in a sort of fixed location. But it is also possible to move the printer to a construction site. If you have space to set it up, then it only takes a day to set up and a day to break down. So if you were working for a couple of weeks making these structures, you could certainly move it to your site, do the work there, and take it away again afterwards. That avoids all of the delivery issues you normally have with precast and prefabricated concrete structures.
I'm Peter Goring. I spent 25 years as a technical director with concrete subcontractors and also main contractors. And so I've had a lot of interest for a long period of time in concrete construction and how can that be made more efficient. I spent a lot of my time looking into innovations and how they could be applied to the construction industry. 3D concrete printing has an opportunity to really change the way things are built off-site. One of the advantages of minimass is that those forms can now be made economically and give us a good, efficient and low-carbon solution.
We're here at the Constructionarium in Bircham Newton, North Norfolk. It's a lovely day and it's all happening. We've had a great deal of support from Constructionarium. The guys on site have been fantastic. They're really working hard for us and with us. This is a place where lots of progressive construction ideas have been tested in the past. And for us, we're planning, of course, to build the bridge for the first time, but then we're donating the components to Constructionarium for their use in the future. That means that students and companies will be able to come and rebuild the bridge, which is fantastic for us because it gets to show off the fact that we can disassemble, reassemble as many times as we like.
Constructionarium is all about turning theory into practice. This fantastic project that we've got behind us moves that forward an extra step. It's not been done before, it's not been seen before, and it's a real privilege to be able to host it here at our fantastic facility. We have 17 projects in our portfolio, of which 4 of those are low carbon, This fantastic low carbon footbridge from Minimass will complement those additional projects. And part of having low carbon projects means that we are trying to educate the youngsters that are coming through college and university into the new ways of working with materials.
It's really exciting that Minimass have chosen the Constructionarium to demonstrate their prototype project. The Constructionarium was set up 20 years ago as a really good way of teaching students how to build projects. The projects we chose initially were very iconic, the Gherkin and the Millau Bridge. So the Minimass project with the efficient beams, the lightweight bridge, is a really good way of reflecting where the industry is moving towards low carbon, low material usage, low energy and off-site manufacturing. So it's a great use of the product and a great example of how it can be used going forward.
Post-tensioning is a process whereby you have essentially a steel cable, which is made up of 7 wires that are wound around each other to give you a 16mm diameter cable. What you then do is you pull those cables during the construction process with a jack, and you put a tension force onto them. Post-tensioning is important for our beams and for this bridge because it allows us to take extra load. We do a first stressing where we put a small amount of the force onto the strands, typically 5 to 10% of the capacity of the strand. And what that does is it engages the anchors at the 2 ends of the beams and it tightens everything up. It puts the concrete into compression and it gives you the performance of the complete structure. You're then able to pick it up, move it around, do whatever you need to do on a construction site. When you've placed it in position and you've applied any additional loading, which could be a floor, slab, a roof, it could be anything that the beam is supporting, you would then typically pull the strands a second time, which takes out any of the actual deflection caused by that load that you've applied.
We're delighted to have this opportunity to showcase Minimass to the industry. So that's from a technical, cost and carbon perspective, but also from a procurement, warranties and insurance perspective. With this pilot project, we expect to be able to convert that interest into commercial contracts over the coming months. And that will range from footbridges to cycle bridges to temporary works to start with.
When we're looking at tenders, we're looking for unique methods that can respond to the client's requirements, which will set us apart from the competition. The way that Minimass have developed their on-site and off-site methods enables contractors to come up with economic, efficient solutions that will give them an opportunity to win a project.
Going forwards, Minimass has a vast range of applications, from industrial to offices, from supermarkets to schools. Basically anything from 6-metre span upwards, and for us, the longer the better, anything that a crane can lift. Services can actually be run through the beams, and that really helps with floor-to-ceiling heights. And the visibility of the components improves safety, allows for easy maintenance, replacement and disassembly, boosting lifespan and promoting circularity. We currently work with concrete and steel, but Minimass can work with a variety of materials, and that includes the low-carbon concrete equivalents when the supply chain has adjusted. That will enable us to reach true net zero, but at a much lower cost than would otherwise be possible.
I'm looking forward to the launch event on Thursday. That's going to be the first time that we've invited people to come and walk on the bridge, see the beams for real. So people will be able to see the beams, touch the beams, and get a real understanding for the technology behind the beams.